equal to 4/3. Is that right? 4/9. OK. Then in the weak market, the maximum willingness to pay of anyone is 1. The quantity is 1. If we charge price 2/3, the quantity is 1/3. The willingness to pay, the vertical distance is also 1/3. And so we get 1/9 over 2, 1/18. So that gives us 9/18 equals 1/2. Plus the firm makes 2/3 times it sells 1 unit. So that's 1, right? So we get 3 halves as the total surplus created, right? So that's not what I got there, but it still is 3 halves. OK. So now let's figure out what the social surplus is in the weak market. I mean, sorry, in the discriminatory case.
Wait, sorry, you said the firm's going to make 2/3, right?
Yeah.
And the supplier, the consumer's making 1/2.
Oh, so that's not right either. 1/2 plus 2/3 is what? 3, 6 plus 4, 6, 7, 6. 7/6. How do you like that? Even better, even better. OK, 7/6. Now let's try to figure out what happens in the discriminatory case, right? OK, so in the firm is going to make, in the strong market, he sells 1/2 in each of the 2 markets, charges 1 in the strong market and 1/2 in the weak market. So that gives him profits 1/2 times 1 plus 1/2, 3 halves, right, equals 3/4. So he's clearly doing better, right? He's making 3/4 as opposed to 2/3 in the other case. Now, what about consumer surplus? Well, in the weak market, we're now doing a price of 1/2. So that's 1/2, 1/2 divided by 2. So 1/8, right? Yeah. OK. So that's 1/8 in the weak market. So the consumer surplus went down that we were earning in the weak market, right? But no, it went up that we were earning in the weak market. It was 1/9, and now it's 1/8, right? But in the strong market, if we charge a price of 1, right, we're going to get a distance of 1/2 here and of 1 up there, right? And so that gives us 1/4 as the surplus in the strong market as opposed to 4/9. Yeah?
In the strong market, is it in? Oh, never mind. Sorry.
OK. So we've got 1/4 plus 3/4 is 1 plus 1/8, which is 9/8, as opposed to, what did we come up with?
7/6.
So this is 1/8 above 1, and the other one is 1/6 above 1. So the answer is still right, even though the math is completely wrong on the slide, which is that the non-discriminatory outcome is better than the discriminatory outcome. OK. Now, that was tedious and obviously confusing because we got it wrong like about 4 times along the way. Yeah, Jacob?
So you said consumer surplus for the weak market went down?
Went up.
Okay, went up.
From discrimination.
Okay.
And in the strong market, it went down. Now, okay, why is it the case intuitively? Let's give an intuitive argument to avoid having to do all this messy math. Intuitively, why is it the case that social surplus in total went down? Kevin, can you give an intuitive reason?
So intuitively, the people, so it's consumers from the different market who's buying the product now.
Yeah.
And those were and now like switching to the discriminatory market.
Yeah.
Means that they're switching the buyers to the ones who would gain less surplus because they value
exactly.
less.
Exactly. So under no discrimination, and under discrimination, we sold the same total quantity, right? 1 unit in each case. But under discrimination, more of those buyers are in the weak market than without discrimination. And people in the weak market typically value the good less than people in the strong market do. So you're reallocating goods from people who are willing to pay a lot from them to people who are willing to pay less. That's happening because different prices are being charged in the different markets, right? And so the discrimination is harmful even though it leaves the total output the same. Okay. So we found here that output was unaffected and that welfare and consumer surplus in total went down, right? This is obvious even though the firm made more profits. Now this is obviously a very specific example. Both of the demands we had were linear. Turns out that more generally for any linear demand, if each market has linear demand curves, then discrimination will be harmful to total welfare, will reduce consumer surplus, will leave output unaffected, and will raise the firm's profit. That's true for any 2 linear demand curves. But more broadly, if both markets are served, as was the case here, without discrimination, then output may go either up or down when you discriminate, and welfare might go up or down, and consumer surplus can go up or down. And if the weak market was initially completely unserved, if you were charging such a high price that nobody in the weak market was buying it, then discrimination can only be beneficial because all you're going to do is charge a lower price in the weak market, right, and get at least some consumers, and that can't be bad for anyone, right? Turns out that if you look into this more, everything ends up depending on pass-through rates. So the key thing is that the pass-through rate in the weak market, if the pass-through rate in the weak market is bigger than the pass-through rate in the strong market, then prices are going to fall by more in the weak market than they rise in the strong market, basically. And that's going to lead you to that's going to make it more beneficial. On the other hand, if the pass-through rate is greater in the strong market than it is in the weak market, it's going to tend to be harmful. You can derive a bunch of analysis related to this, which is probably not that relevant for you guys. You can look at the papers if you want to see it. But the basic principle is that discrimination can be good or bad. The only really consistent pattern is that there's a redistribution of resources from the people who are in the strong market to the people who are in the weak market and to the firm. Okay. So this paints a bit of a complicated picture, and the results seem a bit puzzling, right? Everything seems to be ambiguous and to depend on the details, but we had this strong intuition that Joe was expressing before, that just as in perfect price discrimination, you should think that consumer surplus should go down, firms' profits should go up, welfare should go up, and output should increase, right? That's what first-degree price discrimination indicates. And it seems kind of crazy that third-degree price discrimination could do all this different stuff, could go any which way, even though it's sort of obvious that at some point, if we keep third-degree price discriminating more and more, we're eventually going to converge to first-degree price discrimination. Because if we keep breaking up the population into more and more little groups, right, eventually we're going to be where we were before, right, at first-degree price discrimination, right? So even though things are quite ambiguous, I think that that's actually misleading. I think that in reality, the typical way that you can slice up a demand curve into multiple demand curves is such that you do actually get exactly the effects that you would predict, that welfare goes up, that output goes up, and that resources are redistributed from the consumers to the producers. So let me give you one simple example of why I think that this is sort of the wrong way to think about the market demand curve being sliced up. So notice that this demand curve, the pooled together market demand curve, has a kink in it. Now, we never draw demand curves that have kinks in them, right? And yet we sort of took a two smooth, separate demand curves and then put them together, and we got this kink demand curve. That seems like a pretty weird way to think about splitting up the market. The market has this kink, and then we sort of split it somehow. So here's maybe a more natural way to think about it. Imagine we have a demand curve like that, and we're just going to slice it at some point. We're going to say, everyone who's willing to pay more than that amount is in market A. Everyone who's willing to pay less than that amount is in market B, right? Now imagine that before this happened, you were charging a price up there, right? Well, then the low market was unserved before, right? And so clearly it's beneficial to price discriminate, right? Because all you're going to do is start charging some price to these guys. And the price that you're going to charge to these guys is exactly the same as before, right? Because you're still facing the same group of people. Conversely, imagine you were charging a price down here, and now it gets sliced up, right? Well, what price were you going to charge to people up here? Well, you're just going to charge them this price. Why? As long as your marginal revenue is decreasing, you're now on the same demand curve at a point with higher marginal revenue, right? Because we just went up that demand curve. So we're going to clearly charge at this point here, right? And in this market, we're going to charge a lower price, right? Because we're losing less profits on the inframarginal sales, right? So the price falls here, and here it's such that everyone gets served. And therefore, welfare is going to tend to increase. Output's going to increase. And typically, you're going to get more redistribution from the consumers to the producers because the monopolist now captures that area up there from them. So that's a simple example of, I think, a much more natural way to think about splitting demand curves, where you do get exactly the effects that you would expect. And there's a problems set for the other class that you can look at the solution for starting this afternoon when I post it, which goes through the logic of this in a lot more detail. OK. So one common application of price discrimination is to auction design. Joe, could you explain how the reserve price in an auction is sort of like the price that a monopolist sets?
As you increase your reserve price, you decrease the percent chance that you're going to get a sale, but you increase the average sale price.
Exactly right. Yeah. Really, the only difference between the monopolist